All right, so let's start with a blank slide here and let's talk about what the ellipse equation, what to do if you're given an ellipse equation and it's not in general form. And the answer there is we're going to need an old skill, completing the square. I'm going to be lazy and I may abbreviate complete the square by drawing a square in the future. So, well, that's actually the tool we need is actually the method as well. So if you're given an equation, not in general form, our method is going to be complete the square. And then, because the equation of the ellipse has to be equal to 1, and then we're going to set whatever we get equal to 1 just using regular old algebras. Okay, so we're going to review completing the square in the middle of an example. So, no, we're not. We're just going to start by reviewing completing the square. Review, complete the square, the process of completing the square. Our goal here is to make something we're given, say it's 4x squared minus 8x plus 4 equals to 0, into a square. We want it to be x minus some number squared. That's the square part of it, equals some other number, because it turns out it will no longer be equal to 0. It'll be equal to something else over there. This is when you've done this, you've said to complete. When you have this format, you've said to have completed the square. So the first thing you need to do is move the other number, or the constants, so the non-variable expression, to the other side. There are alternate ways to do this, but I think this is the easiest for most people. So we're going to take that 4x squared minus 8x plus 4 equals 0, and we're going to move it to the other side by subtracting it away on both sides to get 4x squared minus 8x plus equals to negative 4, An important thing and easy to miss when you're completing the square is you need to have your first coefficient on your x squared be 1. So we need to make this thing into 1 squared. You can just divide everything by 4, but you know what? It's safer, better, more mathy to factor out things if possible, and then multiply through. I disagree. You know what? Let's divide everything by 4. 4x squared minus 8x equals negative 4. It's the same thing as multiplying by 1/4 through on both sides. Divide by 4, divide by 4, divide by 4. We don't really care what happens as long as we get our goal, a 1 coefficient in front of that x squared. I'm going to just say it reduces away, and we don't typically write it, so just x squared is what you need. Minus 2x is equal to negative 1. Now, once you have that, now begins the actual steps of what we need to do to generate the completed square here. What we're going to do is we're going to, what I like to call, make room, and here's the key, add the value b over 2 quantity squared on both sides. Okay, so ready. What do I mean? X squared minus 2x plus, well, we're going to add something there, so we'll make room to add it, minus 1 plus, well, if you add something to one side, you have to add it to the other side. So there you go, make room to add it on both sides. Now, the idea here is that this looks an awful lot like what we think of the traditional labeling for quadratic formulas, or quadratic equations rather, expressions ax squared plus bx plus c. So the number, the coefficient out in front of the x term is going to be your b. So what is, this tells us that b is equal to negative 2. So now we're going to calculate b over 2 quantity squared. Negative 2 over 2 quantity squared, simplifying the parentheses first to get negative 1 squared, which is just 1. And so the process of adding this 1 to both sides, that b over 2 squared, we're going to slap that in on both sides. Okay, so we've got that, and I'm going to try and squeeze this into this slide here. The next and fourth step, The fourth step is to factor the resulting perfect square. And sometimes if you get tricky factoring, it will always be x plus b over 2 the quantity squared. But you can always work your way to coming up with that without having to memorize it, even if it's ugly fractions, we can do it. So what did we have? We had x squared minus 2x plus 1 equals to negative 1 plus 1 on the right. I'm going to simplify that to 0 as we go. So now this has been turned into something that we can turn into our goal expression here, a perfect square. But don't think of it like that. Think, hey, that looks like something that I want to factor by doing the two factors like we're used to. What times what gives me x squared? Well, x times x. And what times what gives me 1, 1, and 1. To get negative 2 in the middle, they both have to be negative. And sure enough, negative 1 times negative 1 gives us positive 1. Everything checks out. We've nailed it. And now, by getting clever and saying, hey, those are the same factor being multiplied by itself twice, we can write it with an exponent as x minus 1 squared equals to 0. We've done it. This is the completed square, if you will. This is a coincidence. It does not have to be 0. It just happened to be 0 in our example. So that was meant to be a quick review of completing the square because we're going to now use it. So let's do an example. Our example is going to be this expression, 4x squared plus y squared minus 8x plus 4y plus 4 equals to 0. And what we're going to do here is we're actually going to complete the square twice, once for the x terms and once for the y terms. I'm going to go ahead and do them separately. Once you've done a few of these, you can end up kind of doing them at the same time. Now let's do them together. You guys got this. Ready? First things is we're going to group all the x's together and group all the y's together. 4x squared minus 8x plus y squared plus 4y. Well, the step for the first step of completing the square was to get that number away to the other side. So kick the constant over to the other side, and so we'll get that negative 4 on the right by subtracting 4 on both sides. Okay, so here we are. Now, you can't divide everything by 4 here. Otherwise, you're going to mess up that y squared, which is looking pretty good right now. So here's the game. We're going to get a little bit clever here. We're going to imagine that we're attacking just this x. So yeah, I'm going to do just the x, completing the square first. So I'm going to imagine that I've made room to add whatever number I need to on both sides. But I don't have what I need. I don't have 1x squared. Well, to make that happen, I'm going to factor out this 4 to get x squared minus 2x plus my blank area. We're going to figure out what that is in a minute. Plus y squared. We don't care about the rest of this, but we're going to bring it along so we don't forget about it to get negative 4 plus my whatever on the other side. So b over 2 squared. All right, so b over 2 squared. b is equal to negative 2. By the same exact work we saw on the last page, we're going to come up with that b over 2 squared equals to 1. So I'm going to put a 1 here because we're completing the square just within those parentheses. But think about this a little bit. What number are you actually dividing, what number are you actually adding to both sides? Well, because you're not adding 1 within a parenthesis on the right-hand side of the equation. So in order to truly see what you're adding, you would have to first redistribute these numbers, and you would get 4 times 1. Sure enough, you're actually adding 4. And that's just when you have a number factored outside that you have to kind of think through that a little bit carefully. Because 4 times 1 would be 4, is what we're truly adding. Okay, now, by doing that, we should be able to factor this thing. And this is the same example we just saw on the last page. It would be x minus 1 times x minus 1. So we're going to write that as x minus 1 quantity squared because we just did that example. And we're going to say, okay, x guy done. Now we are going to focus on doing the y guy, completing the y square. So to do that, we're going to have plus y squared plus 4y. Leave a little bit of room because we're going to leave a blank to add our y expression. And we're going to simplify negative 4 plus 4 is equal to 0. But now we're going to add a y guy to both sides. And for y, b over 2, b is equal to 4 in this case. So b over 2 quantity squared is going to be 4 over 2 quantity squared is equal to 2 squared is equal to 4. Funny, but that's okay. We did the math right. It must be right. So we don't have any tricky factoring going on here. We're just straight up adding 4 to both sides of the equation. And now if you look at this expression, 4 plus 4y plus 4, well, that looks like something that ought to factor, and it will because of the process that we just did. But let's think it through just in terms of factoring. What multiplies to 4 and adds to 4? 2 and 2 come to mind. And to get positive 4y, we did positive 2y and positive 2y, which conveniently, positive 2 and positive 2 multiplies to positive 4 as well. So in the interest of saving a little bit of writing here, I'm just going to drop the rest of the expression down and rewrite that. 4 times x minus 1 squared. Plus, well, that's the same factor multiplied by itself twice. That's what it means to be a square, something squared, and we've completed the y square, is equal to, what do we have on the right-hand side? We have 0 plus 4 gives us 4. Well, that's great. So we completed the square a couple times, but the equation of a ellipse is supposed to look like something equal to 1. So what can we do to make this thing equal to 1? Well, the problem child here is to think about, all right, what do we need to do? The logic actually flows from the right to the left. We're going to divide this 4 by 4 to get 1. And whatever you do on the right side, you have to do on the left side. So we'll divide by 4, which is, again, the same thing as multiplying everything through by 1/4. And what do we get? We'll do the math and see what happens. Well, x minus 1 quantity squared, that's fine, plus y plus 2 quantity squared over 4 is equal to 1. And you've got yourself an ellipse. Don't worry about the fact that we don't have a denominator underneath the x term. We could just slap it over 1. There, now it matches format perfectly.